Hello, everybody. Welcome to this month's webinar, which is the last of our year. We're very happy to have with us today Nikhita Kogar from the Good Foods Institute, and she's the senior lead scientist for the plant-based pillar at the Good Food Institute. Prior to joining GFI, she worked in food and biotechnology product development, most recently as an innovation scientist at Beyond Meat. She holds a bachelor's degree in physics from the University of Illinois at Urbana-Champaign and a PhD in material science and engineering from Northwestern University. Welcome, Nikki, and so happy to have you with us today.
Thanks for the introduction. Hi, everyone. My name is Nikhita Kogar. I'm a senior lead scientist here at the Good Food Institute. I'm really excited to be here today. Thank you, Earthshift Global, for having me. I'm excited to talk to you all about GFI and what we're doing to promote the future of meat and surviving the environmental impact of alternative proteins. So today we're going to be talking a little bit just about GFI in general and alternative proteins. We'll be focusing on plant-based proteins, and we'll talk about a review of the life cycle assessments to date for plant-based meat, followed by some final discussion and a question and answer. So for those not yet familiar with us, the Good Food Institute is a 501c3 nonprofit that is developing the roadmap for a sustainable, secure, and just protein supply. We are 100% powered by philanthropy and have earned GuideStar's Platinum Seal of Transparency, which is an honor obtained by fewer than 1% of nonprofits. GFI has almost 200 staff and 6 different affiliates around the globe, and all of us focus on 3 key areas. First, our science and technology team works to advance foundational open access research in alternative proteins and create a thriving research and training ecosystem. Our corporate engagement teams partner with companies and investors across the globe to build the alternative protein ecosystem through investment, innovation, and supply chain development, all faster than market forces alone would allow. And finally, our policy team advocates for fair policy and public research funding for alternative proteins. The key question we're working to address here at GFI is how will we feed 10 billion people by 2050? And how do we do that sustainably, efficiently, and safely? As we'll discuss today, industrial animal agriculture is in the top 2 to 3 most significant contributors to the world's most pressing environmental issues. But in fact, it sits at the intersection of many of our most pressing issues even more broadly. Most people think of animal suffering when they hear alternative proteins, and that's very true. 80 billion animals a year are slaughtered for meat, and that number is growing. But it's also a likely driver of the next global pandemic due to the zoonotic origin of disease and antibiotic use. Over 75% of emerging human pathogens are zoonotic in origin, and this is often made worse by the fact that most antibiotics are used for animal agriculture, something over 70%. Some estimates put the projection of annual deaths from antimicrobial resistance over 10 million by 2050. It also contributes to global food insecurity and environmental devastation due to inefficiencies that we'll get into today. But a lot of estimates show animal agriculture accounts for anywhere from 15 to 30% of global greenhouse gas emissions. Despite the inefficiencies of the system and despite growing awareness, meat production continues to rise. Here we're looking at global meat production from 1961 to 2021, which shows sharp increases across the world. And primarily this is driven by factory farming, this meaning raising more animals with fewer and fewer resources. It also shows almost no signs of slowing down. So here we're looking at projections for meat demand based on 2005 levels compared to what we project in 2050. Essentially, we're expected to eat a lot more meat by 2050, and particularly a lot more chicken. You can see the rise here is a bit steeper than the other animal products shown here. That meat will have to come from somewhere, though hopefully it doesn't have to come from the same system that we've been using to produce it. So why not just eat plants? Well, current surveys put the amount of vegetarians and vegans in the population up to 10 to 15% sometimes. But surveys that ask respondents to actually list everything that they eat on a given day include meat. So that's probably a self-report bias. Our best estimate is that about 6% of the population is vegetarian or vegan. And it's true that a lot of these consumers want mostly whole foods. That's plant proteins such as beans and lentils, tofu, tempeh, seitan, those things that have been around for a long time, and more veggie-centric meat analogs like black bean burgers. However, flexitarians and omnivores, as demonstrated by a study where they were asked to how they want to increase consumption of plant-based foods, both at home and outside the home. The most popular and fastest growing survey responses among many, including eat more salads, eat more legumes, was to seek out more plant-based meat. So the vast majority of consumers, flexitarians and omnivores, gravitate towards more meat-like products. And that's where we come in. So here at GFI, our approach to the challenge that current meat production is unsustainable is to accelerate the field of alternative proteins, more efficiently making them from plants, fermentation, or cultivating directly from cells. So instead of asking consumers to give up the foods that they love, we aimed to change the default option. Ultimately, our goal is to make meat, but in a better way, and also make meat that is just as convenient, tastes the same or better, costs the same or less, but most importantly is sustainable, secure, and just. Ultimately, our goal is to create a world where alternative proteins are no longer alternative. So what do we mean by alternative proteins? Well, GFI has this broken down into 3 pillars or platforms. First, plant-based meat biomimics meat by using plants as building blocks. These products look, taste, and cook like conventional meat. You've probably seen some of these in the grocery store, like the Beyond Burger, Impossible Burger, and now countless other meat analogs hitting the market. The second pillar is fermentation, which is increasingly being used as an enabling technology in the industry. It allows for the production of functional ingredients, but also standalone protein sources like the bacon shown here in this slide. And then the last pillar is cultivated meat, which is identical to animal meat at the cellular level, but is cultivated directly from animal cells outside. We'll be focusing on plant-based for today's presentation, but I want to note also that fermentation and cultivated meat have seen a lot of notable activity recently, including the first FDA approvals of cultivated meat in the United States this year. You can now even have it at 2 restaurants in the US. But before we dive into plant-based meat, it's also important to note that ultimately we see these 3 pillars or alternative protein platforms as one large industry where products are produced across the spectrum, utilizing ingredients from one or more technology. So a few examples are shown here, but you can imagine using plant-based scaffolds for cultivated meat production, or fermentation-derived enzymes for plant-based protein functionality or growth factors for cultivated meat. There's also a lot of work going on for cultivated fat for plant-based proteins. And in fact, we'll even look at one example today in the well-known Impossible Burger, which uses fermentation-derived hemoglobin, the signature ingredient that gives it the bloody appearance and meaty taste. So, but back to plant-based meat, where the market is growing quickly. Here we're seeing the global plant-based retail market from 2017 to 2021. And it's projected to grow. So this slide displays both US and global market projections for plant-based meat from various sources. In the US, forecasts estimate the plant-based meat market will be $30 to $40 billion in about 10 years, a little less now. Globally, banks such as UBS and JP Morgan forecast market sizes of 85 billion and 100 billion respectively. These numbers may have shifted slightly in recent years, but it's an important growing category. So with those kinds of projections, it's important to consider how plant-based meat is made and the environmental impacts. Here we're showing the entire value chain for plant-based meat, how it's made in a nutshell. Each one of the headings here is a vast area of science and technology, but to give you just a very quick overview, plant-based meat production begins with crop development and cultivation, where even new crop sources are being researched right now to make better inputs for plant-based meat. Those are then processed and functionalized for producing ingredients, followed by end product manufacturing. This includes the very important step of protein texturization using various methods such as extrusion, alternative fat production, flavor production, and then of course, figuring out and producing the correct mix of ingredients and processes to create the desired smell, texture, and structure of plant-based meat and the manufacturing steps. And then you might be thinking, well, that sounds plenty more complicated than raising and slaughtering an animal. And in some ways, that's right. There's typically more crops and more steps involved in producing plant-based meat compared to animal-based meat. Here's an example process diagram from a study that we'll be looking at today, showing cattle production on the left from two different sources and the production of a plant-based burger on the right. The plant-based burger on the right uses 16 different crops with legume-based additives, fibrous and oil ingredients, legume and cereal protein, flavoring, seasoning, and bulking ingredients, as well as vitamins for fortification. You can see more inputs and as a result, more processing steps before the paths converge for final production, distribution, packaging. Of course, plant-based products exist on a wide spectrum, so there are some that have a much simpler process diagram and fewer ingredients. Here's an example process diagram showing again cattle production on the left and the production of plant-based meatballs on the right using just pea protein as an ingredient and minimal other ingredients as inputs, which shows a much different picture of the process diagram. So the key question we want to address today is, how do the environmental impacts compare, taking stock of the existing literature on the subject? So today we'll pull from several life cycle analyses, both from peer-reviewed literature as well as some that have undergone ISO review. Those are typically from plant-based meat manufacturers. The three we're looking at today are from Morningstar Farms, Beyond Meat, and Impossible Foods, including that fermentation-based ingredient. And there are many different products surveyed and compared here, from burgers, meatballs, patties, chicken analogs, pork analogs. And all of these studies, of course, differ in their recipes, in their scope, the functional units, allocation, data scale. I don't have to tell this audience all about that, but, and of course, impact categories. So it's really difficult to compare one-to-one. And instead, we'll take a tour of a few impact categories and how they're presented in these 7 studies. And our focus will be on the percent difference between conventional proteins and alternative proteins using the formula shown here. So hold on to your seats while I present a series of very exciting tables. So first up, we'll be looking at greenhouse gas and looking at these LCA that compare producing a type of plant-based meat over conventional meat reduces greenhouse gas by 30 to 91%. That lower end comes from the study by Morningstar, which is a popular plant-based meat manufacturer. Hopefully you've seen some of their products around. They produce everything from burgers, even ready-to-eat meals. And their LCA also looked at a suite of products from crumbles that are meant to replace ground beef, a few different types of plant-based burgers, and then pork and chicken patty replacements. So the lower end of that greenhouse gas emission number comes from the comparison of their sausage patties and chicken patties. And that basically tells us that comparators are important. The amount of greenhouse gas from beef is much higher than pork and chicken, but it's also important to look at a variety of different impact factors. So the Morningstar study, for example, shows a greater benefit in water use, pollution effects, and ecosystem quality when producing their sausage patties over conventional sausage patties, even though the greenhouse gas benefit is about 30%. Next up, water use is reduced by 72 to 99% when producing this suite of plant-based meat products over conventional meat. And I want to note here also that a couple of studies use water scarcity instead of direct water use, which really highlights the importance of geography. So here, looking at this plot of per capita renewable freshwater resources, we see that more freshwater resource per capita is available in Brazil than the US, Western Europe, and African countries. And that's taken into account when measuring water scarcity because it's typically a measure of the water needed, used, or water demand compared to the resources available. So the couple of studies that look at water scarcity, now I'll show one of those results. So essentially here we're seeing that plant-based meat products reduce water scarcity only slightly compared to beef produced in Brazil, about 2 to 37%, and South Africa, compared to beef produced in Ireland, up to 71 to 74%, and the US. However, other impact categories vary widely by geography, and as we'll see later, producing beef in Brazil, for example, is associated with other impact categories, such as the carbon opportunity cost. So next up, a quick look at pollution. That is reduced by 55 to 99%. Of course, this is a wide and nuanced topic. Here I'm showing some of the highest difference categories that really spans a range from eutrophication, particulate matter formation, even sort of larger aggregate impact categories like health impact of pollution, or more generally. But essentially, because alternative proteins do not emit ammonia, particulate matter, and hydrogen sulfide, that leads to less air pollution. And because no animal waste is emitted and there's less use of fertilizer and crops, there's much less nitrogen and phosphorus released, leading to eutrophication. There's also less use of pesticides as a result, less use of antibiotics and pathogens, bacteria that are released into the environment from waste that affect the ecosystems and communities around them. But for more details, I highly recommend taking a look at these couple of reports, one from the CDC and one from the FAO at the UN, that detail the impacts of animal agriculture to both the farmers and nearby communities, as well as its impact on ecosystem health. And this is the last time I will show this table, I promise. But that's to look at land use. So land use decreases by 47 to 97% when producing plant-based meat over conventional meat. And again, those lower numbers are in comparison to chicken and pork. But this, like all the others, is a very nuanced impact category that we'll spend a little bit more time with, as it has direct relationships with greenhouse gas emissions. So direct land use is one way to look at it, and that's mostly what's reported here. But one way to add a little bit more nuance is to look at direct land use change, which estimates the impact from converting a native ecosystem into land used for agricultural production, taking into account the geography as well. So direct land use change is associated with cropping systems used to provide feed and the need to convert more and more land. This study measured direct land use change when producing plant-based meat alternatives to chicken meat. And it even looks at optimized variants of both of those. So with the plant-based meat, it's looking at a optimized variant that is essentially simulating a higher yielding protein crop. And with the chicken breast, we have this high performance category, which is meant to simulate animal varieties with high food conversion rate or a higher food conversion rate. Although those are typically highly industrialized and may be worse for animal agriculture, they decided to model both. And so we can see that when comparing plant-based chicken with animal chicken, the greenhouse gas impact may be about the same right off the bat. But when you take direct land use change into account, this lighter bar, it looks vastly different, as conventional meat requires more and more land to be converted. Another way to add nuance to land use is by considering the carbon opportunity cost of land. This was originated by a couple of scholars in a paper, but also picked up recently by Our World in Data, showing the carbon opportunity costs of different foods. And you can see here that essentially what it's trying to do is look at the hidden costs of continuing to use land for animal feed and agriculture production, in addition to the greenhouse gas emissions today from production. So the production emissions here in green, where the carbon opportunity cost of land is, production emissions are in brown, and then carbon opportunity cost is in green here, showing the additional benefit. So that's essentially asking, what would it look like if more land was freed up by reduced production of food, whether that's crops or animal products? And essentially that would allow for forests and grasslands to grow, could harbor wildlife and store carbon potentially. So two of the studies that we're looking at in recent years have incorporated the carbon opportunity cost of land when looking at the environmental effects of plant-based meat versus animal meat. So one of them is shown on the right here, and that's looking at plant-based burger production or veggie burger compared to beef burgers produced in Ireland or Brazil. And the veggie burger had a carbon opportunity cost of just 1.5 kilograms carbon dioxide equivalent, compared to over 15 kilograms carbon dioxide equivalent for the beef burgers. So when you compare the greenhouse gas emissions without carbon opportunity cost and with carbon opportunity cost, that further highlights the advantages of plant-based meat. And finally, because we're talking about food, a common question is, how do these products compare nutritionally, and how can that be factored into life cycle analyses? So it's very common to use mass functional units, sometimes energy, such as kilocalories, or protein, which can be comparable. But a more comprehensive measure is the nutrient density unit, which takes into account some other macronutrients. Specifically, it takes into account essential fatty acids, protein, and fiber content of foods, all macronutrients to encourage, as proposed by researchers in the Netherlands. So here we're looking at a study that used both a mass functional unit and a nutrient density unit. And so to arrive at that nutrient density unit, we see this nutrition facts panel of sorts, comparing the veggie burger as well as the beef burger. You can see that energy and protein are fairly comparable, a little bit lower for the plant-based burger, though that's not always the case. But the plant-based burger is much higher in fiber as well as essential fatty acids, which leads to a higher nutrient density unit. That nutrient density unit is then adjusted down slightly for protein digestibility. In this study, they assumed pea protein, though there are more digestible plant proteins such as soy, but they did that adjustment here and adjusted it slightly down, and the nutrient density unit of the plant-based burger was 2.2 compared to 1.35 for the beef burger. So on the right, we're looking at the greenhouse gas emissions from the perspective of the mass functional unit, which gives us a 73% reduction, but with the nutrient density unit, it goes up to 81. So using that functional unit over mass results in an even larger reduction from producing plant-based meat over animal. So why the large disparity? Well, many of these environmental impacts can be traced back to the inherent inefficiency in raising animals for protein. Here we're looking at feed conversion rates of popular animal meats such as chicken, pork, and beef, and that shows just 3 to 13% of the calories in are converted into edible animal meat. With plant-based meat, those calories go more directly to the consumer, which leads to more efficiency in protein production. Alternative proteins also have lower agricultural inputs across the board in terms of fertilizer, water, etc., and more judicious use of resources, plus less impact on the environment from nutrient and waste runoff. But when we look at plant-based meat, where are the major impacts? What parts of the process are causing the environmental impacts? So many of the studies break down the production of plant-based meat into various groups of processes. Here we're seeing one that groups ingredients, processing versus packaging and final distribution steps. And seen here, which is echoed by many others, a large share of impacts are from crop cultivation and ingredient production, as is the case for animal meat. So other large impact areas for plant-based meat are flavoring and seasoning, coconut oil production, and cooking if it's included. Whereas for animal meat, of course, that's crop cultivation, raw material production, so raising the animals themselves, and then processing and cooking. Though the impacts are still lower than animal beef, as we can see here. One area of opportunity for plant-based meat is to transition to more renewable sources of energy, which often account for the largest portion of the impacts compared to animal meat. Another opportunity for plant-based proteins is to utilize side streams or leftovers from commercial crop production, which also moves us closer to a circular bioeconomy from the traditional linear bioeconomy shown here. So GFI recently published an analysis on this, but I'll do my best to give you the main idea, which is that over half of the biomass from the top 8 commodity crops in the US are not put towards food or industrial use. Rather, they are used as animal forage, burned, incinerated, or even put in a landfill or used as fertilizer. But there are large opportunities for all alternative proteins, including protein-rich side streams, protein hydrolysates and sugars for fermented or cultivated proteins, and more. So highly recommend taking a look at this report on our website, which has a deep dive into each of these 8 commodity crops and where the opportunities lie for alternative proteins. But also in general, more LCAs and TEAs are needed on this subject, as well as R&D and investment to realize these opportunities. Finally, data collection and analysis will be an integral part of improving both the development of alternative proteins, as well as creating more LCA and TEA studies moving forward. We'll need data on all parts of the process, from crop cultivation, raw material and ingredient processing, and then of course, end product formulation and manufacturing. So all parts of that process and new technology as it progresses. And eventually machine learning, also using collected data, can expedite this process even further. So to this end, GFI has partnered up with Earthshift Global to produce an LCA. We are studying 6 pathways, 3 plant-based and 3 animal-based for meat production. We're looking at a variety of inputs, so soy and pea, and then different processing techniques, including low and high moisture extrusion. And this study includes a lot of primary data from many sources and will be a very deep dive into both the products themselves and the impact categories. So that is coming in 2024. Please stay tuned. And this builds on GFI's work on cultivated meat, including a full LCA and TEA on the subject. So encourage you to check that out on our website. There's lots of helpful summaries for each type of stakeholder, including technical stakeholders, policy, and even executive summaries. And to close out, I want to emphasize that GFI has a lot of great open access resources for researchers to learn more about the field, as well as funding opportunities and potential collaborators. A really great starting point is the Science of Plant-Based Meat webpage, which dives into each part of the value chain. Link is here. And we also have a massive online open access course and an alternative protein course database for anyone that wants to learn more. And of course, please feel free to reach out to me or anyone at GFI. So thank you so much for your time and attention, and I'm happy to take your questions.
Thank you, Nikki, for such an interesting and comprehensive webinar. Our sustainability analyst, Joel Bonales, will now answer the audience's question. Please welcome.
Hey, Holly, thank you very much for the introduction. And also, thank you very much, Nikki. This has been a very interesting and fascinating presentation. There are lots of questions from the audience, so I'll go reading them one by one. So the first one goes by, do you have data on the comparison to regenerative grazing practices? And this question is, well, based on the fact that, well, maybe, and you can give us more details on that, but that usually the animal-based meat data is assuming the standard industrial factory farm conditions. So is there data on the comparison with these new regenerative grazing practices?
Yeah, I will say, so not all of the studies are based on factory farming conditions. In fact, some of them have sensitivity analyses that are looking at different types of conditions. Our study also in particular is going to be looking at the mix between what is considered typical in the US. But that said, I will also say that our study on cultivated meat actually looked at an even more favorable condition for animal meat production, which is the use of dairy cows for meat production, which typically is associated with a much lower environmental footprint. So those sensitivities do exist out there. I will say that the aggregates shown today have a variety of those built in as well.
Thank you very much. Hope that question is cleared by now. So the next one is a little bit long, but I'll read it directly. So it goes like this. In these flowcharts comparing animal and plant-based meat, I'm surprised they do not include the number of different crops, often three to six or more, byproducts from textile and animal production, minerals, vitamins, antibiotics, and other inputs to animal feed. Beef producers will often list a dozen or more ingredients in their feed mixes. Do you have a recommendation for another source that has a more detailed view of inputs to beef or other meat production?
Yeah, so these may not be shown in the process diagram, but some studies do take into account the chemicals that are used for animal husbandry and everything that's included in the feed basket. I would say, so maybe Joel has a better answer on this, but our study is going to be looking at a bunch of different inputs into that, and that will hopefully be a good resource coming out for everyone in the coming months.
Adding up to that answer, yes, there are lots of mass inflows into the conventional animal husbandry systems, but often they can be included or not in this kind of environmental impact assessments because of their contribution in terms of mass or on the overall impact that they may have on the system. So thank you very much for answering that. So moving into the next one. For communicating with stakeholders, do you think it's best to use the water scarcity indicator, given its difficult interpretation, or actual water use values, not accounting for the regionality impacts?
Yeah, that's an interesting question. I'm going to give somewhat of a cop-out answer, which is I think it really depends on your stakeholder. If that is someone that, where geography plays a big role, then maybe you want to take the time to explain water scarcity. I think there's ways to do that by, pointing to a more general concept and then going into the data. But in general, of course, it's always good to just keep it simple in terms of direct water use. But when needed, I would say water scarcity can be a really great tool.
Great, thank you very much. So another question goes back into the first part of the presentation, the first half, and it goes like, the goal seems to be turning animal-based meat eaters into alternative meat eaters. Have there been studies looking at unintended side effects of the normalization of these products, such as vegetarians who normally don't eat these alternative meat products starting to do that, which presumably is environmentally detrimental, for example?
Yeah, that's a good question. Not that I'm aware of, but I will say that our main market here is to attract more flexitarians and omnivores into the category. The proportion of vegetarians and vegans in the population is very low, and they are just simply not the target audience. We're trying to reach people that are trying to reduce their meat consumption and encourage them in that direction.
Great, that's very interesting. Let's see. Have there been major improvements in the production technologies in the past few years for these plant-based meat products?
Yes, definitely. And we continue to see that in the space. It's been really exciting to watch the technology grow. I think one of the main areas that we're really excited about is texturization and everything happening there, bringing together some of these different concepts from the pillars. So using fermentation for plant-based meat production. Another active area, there's so many, but another active area that I'm personally excited about is alternative fats. So how do we replace coconut oil? How do we enhance the texture and mouthfeel of plant-based products using sort of healthier fats that contribute to a better nutritional profile? So all those sorts of advancements are coming to the market. If they're not there already, there's certainly a lot of research and development happening.
Great. Thank you very much. I think we have room for a couple of additional questions. So one goes like this. If the plant-based meat products are more efficient, why are they still more expensive than the conventional animal meat products?
Yeah. Well, in short, I think it hasn't yet reached economies of scale. These are new products. The supply chains are often decentralized. We're looking at new companies and technology. So you're also taking into account some R&D, some marketing, startup costs. And then lastly, there's also much lower public funding for alternative proteins than traditional meat and dairy. There was a study that actually came out this year that meat and dairy receives about 1,000 times more funding in the EU and US than alternative protein. So all of that kind of translates into that higher price point that we see, although there are projections for when and how we'll reach cost parity, and that is what the sector is driving towards as a whole.
Very interesting indeed. So some of our audience members are very interested in this comparison of the impacts per nutrient basis. So could you give us more details on maybe how does these different nutrients are chosen or should be chosen for comparison in this type of studies?
Yeah, that's a good question. So how those nutrients are chosen, that was actually based on a study that surveyed the nutrients to encourage and took that into account. So essentially, I think it was protein, essential fatty acids, and fiber as nutrients to encourage versus looking at total calories or fat or, micronutrients, as those were a little bit more of a gray area. So the way to come up with those nutrition panels, at least what we've seen a lot of the time, is using a recipe. So something similar to what you might see in a product in a store, estimating the amount of each ingredient, and then using nutritional databases to come up with those comparisons. And I think that's a really great way to look at it, highlight the importance of looking at the nutrition for both of these. So I can maybe link to that study in particular, but you can find it in those couple of papers by Saget et al.
Thank you. Those are great papers indeed. Very interesting and full of detail. So I think we have room for one last question. So the audience would like to know, well, what are some of the biggest opportunities, more specifically for these plant-based meat systems in the valorization of their side streams?
Yeah, so the analysis that we put out looked at the top 8 crops. So that is corn, soy, wheat, sugarcane, tomato, rice, canola, and barley. And it looked at them from an economic perspective. So just considering the side stream volume and the modeled production unit cost for the side streams, as well as an integrated perspective. So in addition to those economic considerations, the environmental impact and the functional attributes. And then it ranked those the side streams from those top 8 crops according to both the economic and integrated perspective, and found that the top candidates for protein isolates, which is what we're looking at for plant-based meat at least, were soy meal, which is unsurprising, as one of the largest commodity crops, corn, dried grain from distilling, canola meal, corn gluten meal, and brewer spent grain, as well as tomato pomace. So if you are interested in that, we would love to chat further or have you look at the resources on our website. Please reach out and check those out.
That's great. Thank you both again, Nikki and Joel, and for another great webinar we've had. Please, audience, stay tuned for next month and next year, where we hope to have a whole new slate of interesting topics. Thank you both again. Bye now.